Hello and welcome to my channel. In this video we are going to solve an example from polynomials. Find the zeros of the following quadratic polynomials and verify the relationship between the zeros and coefficients. Now let us understand first what are quadratic polynomials. They are the expressions where the highest power of x is always 2. So here we can see that highest power of x is 2. Now next it asks us to find the zeros of the following quadratic polynomials. Now zeros or roots or solutions, whatever we call them, they are the values of x that makes this entire expression equal to 0. So what should be substituted in place of x so that this entire equation or expression goes down to 0? We need to find that out. Now to find out the zeros, we are going to use splitting the middle term method or sum product rule. Now in this method, we are going to split the middle term, which is minus 2x, into two separate numbers. Now before that, let us write down the general form of any quadratic polynomial. So the general form of quadratic polynomial is ax to the power of 2 plus bx plus c, where a, b and c are the coefficients in the form of constants of x. Now let us get back to splitting the middle term. So to begin with, let us multiply the coefficient of x square, which is 1 in this case, with the c. So we get it as 1 times negative 8. Take the signs as well. Since it is negative 8 here, so we are going to take negative 8. So 1 times negative 8 gives us a negative 8. Now let us find out the factors of negative 8. So negative 8 factors could be 4 times negative 2, or it could be the reverse way round, that is negative 4 times 2, and then we have 8 times negative 1, and we have negative 8 times 1. So whenever we multiply the factors of negative 8, that is 4 times negative 2 and so on, we should get negative 8. Now this is the product. But we have to also get the sum of these two factors, whichever option we have. The sum should be equivalent to the middle term, that is in this case negative 2. So let us look at the first option. So when we add this, that is 4 and negative 2, do we get a negative 2? We will not get a negative 2, we will be getting a positive 2. So this option can be discarded. Now the next one is negative 4 plus 2. This is a plus 2 here. So when we add negative 4 with plus 2, we get it as a negative 2. So this fits the option. We get it as negative 2. So we choose this one and we can discard the rest. So once this option is chosen, we have to replace the negative 2x by these two factors. So let us write over here x square, the first term over here, and followed by negative 4x, that is we are splitting the negative 2x with negative 4x plus 2x minus 8. Now if you see, if we add up these two, we should get back the middle term, that is negative 2x. So negative 4x plus 2x gives us negative 2x. Next, after this we are going to factorize, that is we are going to group the first two and group the last two terms. Now in the first two terms, we have x as a common term. So we are going to take it out, and within the bracket we have x, which is left out from the first term, minus, now from the second term we have 4, which is left out, plus from these two terms we have 2, which is taken as a common term, and in the bracket we have x minus 4. Now 2 times x gives us 2x, and 2 times negative 4 gives us negative 8. Likewise we choose the common term. Now you have to check that the terms in the bracket are same. If you are getting some different answers, for example if you get x minus 4 here and x plus 4 here, then the factors you have taken is wrong. So this gives you a kind of verification that if both the bracket terms are same, then you have taken the correct factors. Now here we can see that x minus 4 is common in these two terms. We can take out the x minus 4 in one bracket and x plus 2 in the second bracket. Now since in the question they had asked us to find the zeros of the quadratic polynomials, now whatever answer we have got, we have to equate it equal to 0 to get the value of the x. So let us take the first factor, that is x minus 4, and equate it equal to 0. And let us take the second factor, x plus 2, and equate it equal to 0. So here we get x is equal to negative 4 goes on the other side of equal to sign, turning to positive 4, and x equal to plus 2 goes on the other side of the equal to sign and it becomes minus 2. So these two are the values of the zeros or the values of x, which when you substitute in this equation makes the entire equation equal to 0. Now let us look at the second part of this question, where we have to verify the relationship between the zeros and the coefficients. So I have written here again the question, x square minus 2x minus 8, and these were the two zeros which we got. Now zeros for the quadratic polynomials, here we can write alpha is equal to 4, and here we can write beta is equal to negative 2. So this is the representation of the zeros for quadratic polynomials. Now here you can see that I have made a table. Since they asked us to verify the relationship between the zeros and coefficients, so let me write over here. So zeros are in the form alpha and beta, and coefficients are in the form of a, b, c. That is the general form of the quadratic polynomials. So I'm going to write here general format for the quadratics. So ax square plus bx plus c. Now these are the coefficients of the quadratic polynomial. Now what is the relationship they are talking about? Now here sum of the zeros. So sum means we are going to just write alpha plus beta. And here we have alpha as 4 and beta as negative 2. So we are going to add it and we are going to get it as 2. And in terms of coefficients, that is a, b and c, the sum of the zeros is written as the negative coefficient of x, that is negative b, over positive coefficient of x square, that is plus a. Now here let us compare what is b. So in place of b we have negative 2, and in place of a we have 1. So if there are no numbers with x square, we default take it as 1. So a is 1. So let us substitute over here, that is for the sum of zeros in terms of coefficient. We have minus of minus 2. Minus was already in the formula, over 1. So negative of negative 2 gives us positive 2. So we verified that the sum of the zeros are same in terms of zeros or in terms of coefficients. Now let us check at the product of the zeros. So in the product, in case of zeros, we write it as alpha times beta. So alpha we have it as 4 times negative 2. So 4 times negative 2 gives us negative 8. Now in terms of coefficients, we write it as the constant term in this general form of the quadratic polynomial, the constant divided by the coefficient of x square. So we have c over a. Now by comparison, here we can see that in place of c we have the constant negative 8. So we have c equal to negative 8. Let us write down over here negative 8 over a we had seen it was 1. So negative 8 over 1 we get it as negative 8. So we have again verified and confirmed that the zeros, the product of the zeros, is same as the coefficients of the given quadratic polynomial. So this ends the question number 1a. Now let us move on to the second part of this question. Now again here we have to find out the zeros of this polynomial and verify the relationship between the zeros and coefficient. So let us take 4s square minus 4s plus 1 equal to 0, because we have to find the zeros of this polynomial. Now again we are going to multiply the first coefficient with the last coefficient, that is 4 times 1 gives us 4, and now we are going to find out the factors of 4. So we have 2 times 2 as one of the factors, and we have 4 times 1 as the second factor. Now this confirms the product, so we are getting the product as 4. Now let us check the sum. The sum has to be -4, that is the middle term number. Now here we cannot take 4 times 1, because if we add or subtract 4 and 1, we do not get it as -4. So we are going to discard this option, and let us check at 2 times 2. Now 2 and 2 we can take it as -2 times -2. You can see that we can get here the answer as +4, which verifies the product, and -2 plus -2, that gives us a value of -4. So the sum is -4 and the product is +4. So we are going with the second option. So let us split this number now. So we have 4s square, and splitting the middle term as -2s, -2s. So we have -2s, -2s plus 1 equals 0. Now again factorizing it, we are going to group them as first 2 and last 2, and here we have to take out the common terms. So we have 2s as a common number, and in the bracket we have 2s which remains, minus, here 2s is taken out common, so only 1 remains. So we have 2s minus 1, minus, now here we do not have any common terms, so we take the negative common out and write here 2s minus 1. Now you can cross verify it by multiplying -1 with 2s, that gives you -2s, and negative of negative gives you +1. So this is equal to 0. Now again you have to check whether your factors within the bracket are same. So if they are same, then you have chosen the correct factors. It's confirmed. Now again 2s minus 1 and 2s minus 1 is a common factor, so I'm going to take it out in the bracket, 2s minus 1 in one bracket, and in another bracket we have 2s minus, if there is no number we can take it as 1. So it is again 2s minus 1 equals 0. Now let us find out the factors of s, that is 2s minus 1, the first bracket equal to 0, and the second bracket is also the same thing. So 2s minus 1 is equal to 0. So here we have 2s is equal to -1 goes on the other side and it becomes +1. So s is equal to 1/2, and here also it's the same factor, so here we get s is equal to 1/2. So we have the two zeros as 1/2, the same values. And since these two are the zeros, we take the first as alpha and the next one as beta for the quadratic polynomials. Now let us verify the relationship between the zeros and the coefficients. So here we have alpha equal to 1/2, beta equal to 1/2, and here comparing the given expression with the standard expression for the quadratic ones. So we have ax square plus bx plus c. So we have a is equal to 4 by comparison. So in place of a we have 4. Now in place of b we have -4. Take the signs as well. And in place of c we have +1. So let us substitute over here. Alpha plus beta we have 1/2 plus 1/2. So we get it as 1. And here it is -b over a. So we have b as -4. So it becomes negative of -4 over a, which is 4 again. So this becomes +4 over +4. 4 and 4 divides each other, giving you 1. So it is confirmed that the zeros and the coefficients are same for the sum of zeros. And here product, it's going to be 1/2 times 1/2, which gives you 1/4. Let us check for the coefficient. C is 1 and a was 4. So the product of zeros and the coefficient is same. Now let us look at the third subpart of this question. 6x square minus 3 minus 7x. Now here we can see that it is not arranged in a proper way. It should be always arranged from highest power of x to the lowest power of x or towards the constant. So let us rearrange this first. So we can write over here 6x square minus 7x and minus 3. So the first term comes x square, then the x, and then the constant. Once we have got this, let us find out the sum and product of the given expression. So again we are going to multiply the first coefficient with the last coefficient. So we get 6 times negative 3. So we have here negative 18. So we have to find out the factors which all gives us negative 18. So we have 2 times negative 9 or negative 2 times 9, and then we have 6 times negative 3, and we have negative 6 times 3, and then we have 18 times negative 1 or negative 18 times 1. So all these will multiply to give you negative 18. Now once we have got this, let us find out the sum. Now sum is the center or the middle term of the given expression, and here it is negative 7. So we have to choose these factors in such a way that when we add them together we should get negative 7. Let us start with the first option, that is 2 added with negative 9. So this becomes 2 minus 9, which is minus 7. So our first option gave us the proper sum. So we can just discard the rest of the terms without checking them further. So let us now split the given expression and write it as 6x square, and minus 7x splits up as plus 2x, that is the first term we have taken here, and minus 9x minus 3, and this all will be equal to 0 since we are finding the 0 of the polynomial. Now again factorizing them by taking out the first 2 terms and the last 2 terms, we have 2x common from these 2 terms, so 2x will be out of the bracket, and within the bracket we have 3x, and since we have taken out 2x, here we have just 1, so plus 1. And here we can take the negative 3, and in the bracket we have 3x. Since minus is taken out, we are left with plus 1 is equal to 0. Now we see that 3x plus 1 and 3x plus 1 is common. So we take 3x plus 1 as one of the factors, and 2x minus 3, that is 2x from the first term and minus 3 from the second term which was left out, is equal to 0. So now equating each factor to 0, we get 3x plus 1 equals 0, and we have 2x minus 3 equal to 0. So further simplifying this, let us take plus 1 on the other side of the equal to sign. So we have 3x is equal to minus 1, or x will be equal to minus 1 over 3, and here taking negative 3 on other side of equal to sign, we get 2x equals 3, or x equal to 3 over 2. So these are the two zeros of our equation. So let us take minus 1 over 3 as alpha, and let us take 3 over 2 as beta. Now once we have got the zeros of this polynomial, let us verify the relationship between the zeros and the coefficient. So here I have written alpha as minus 1 over 3 and beta as 3 over 2, and this was the expression we got, 6x square minus 7x minus 3. And writing the general form of quadratic polynomials, we have ax square plus bx plus c. Now comparing, a values is 6 and b value is negative 7 and c value is negative 3. Now let us substitute the values over here. Alpha plus beta, so here we have negative 1 over 3 plus 3 over 2. So taking the common LCM, here we can write times 2 and times 3 So same thing we are going to do to the denominator, times 2 times 3. So this is going to give us negative 2 over 6 plus 3 times 3 is 9 over 6. So this is going to be 7 over 6. So let us check with the coefficient. This was minus b over a. So we have minus, and b value we have here as negative 7 over a is 6. So we get negative of negative, positive 7 over 6. So we have verified that the zeros and the coefficients are same, 7 over 6 and 7 over 6. Let us check with the products. Alpha is negative 1 over 3 and beta is 3 over 2. So we have from the fractional multiplication 3 and 3 divides each other. So we are left with negative 1 over 2. And let us check over here for c over a. C we have here as negative 3 and a we have it as 6. So again these two will divide, 3 one times, 3 two times, giving us negative 1 over 2. So again you can see negative 1 over 2, negative 1 over 2. The zeros and the coefficients are equal. So this is how we verify the zeros and coefficients of the quadratic polynomial.